Associate Professor in Oxford Medical College and Research Center, and she has numerous national and international publications to her credit. We welcome you, Dr. Divyalakshmi. Over to you.
Thank you, sir. Thank you for the introduction. Hope my screen is visible.
Yes, doctor.
Yes, ma'am.
Hope I'm audible too. So thank you, sir, for the introduction. Continuing with the topic, infrastructure design in the medical laboratory. The objectives of today's talk are to list the different types of medical laboratory infrastructure, to describe the considerations to be undertaken while designing a lab, to lay out and workflow of laboratory, to understand the specific regulatory requirements and guidelines laid down by NABL. In India, the medical laboratory services are integrated with the three-tier public health system at the primary level, secondary, and tertiary level. Apart from that, there are reference laboratories, research laboratories, and specific disease reference laboratories to provide services for complex and special tests. Apart from that, there are labs which are associated with hospitals, labs at the private clinics, and standalone diagnostic labs. So whatever it is, the medical laboratory or clinical laboratory, these all labs carry out certain tests or all tests on the clinical specimens to obtain the information about the health of the patient that will help in the diagnosis, treatment, prevention of the disease, and for the clinical research. So, infrastructure of the laboratory varies with the requirements of the clinical research or the services provided by the laboratory. But the basic requirements should meet the regulatory and international standards. So the infrastructure of the laboratory can vary depending upon whether it is a small lab, medium lab, or the large size lab. And it also depends upon what kind of services you will be providing. Whether you are giving only the hematology and basic biochemistry reports, or you are giving even the hormones reports, or even histopathology is reported, culture sensitivity reports are also reported. Depending upon the requirements, the lab infrastructure can vary, but there are certain basic requirements which should be followed in all kind of labs, let it be a small lab, big lab, or medium-sized lab. Infrastructure of the laboratory will directly impact the quality of the research data, efficiency, and safety of the laboratory workers. Infrastructure of lab is very important to ensure that safety of the laboratory workers is there and also to provide good quality report. So the management of the laboratory will be responsible to provide good, adequate resources to the staff to ensure the efficient working of a laboratory. So we all are working in different various kind of laboratory. So we all know what are the functions of medical laboratory. We are basically handling to give a good, comprehensive and accurate analytical test results.
Sorry to interrupt. We lost your presentation. Can you re-present it?
From where, sir?
This slide.
Functions of medical laboratory?
Yes, ma'am.
Okay. So we all are working in various kind of laboratory. Whichever type of laboratory we are working in, whether small lab, medium or large size lab, we are mainly tend to work to give a good, comprehensive and accurate analytical test result, which will or which should assist in confirming or rejecting a diagnosis given by the clinician. Also, our reports will help in telling the prognosis of the disease and also for the follow-up of the treatment of certain disorders.
I'm sorry to interrupt again, ma'am. Can you re-present your slide, ma'am? We are not able to see the presentation.
Okay. Is it the same for everybody, sir?
Yes, ma'am.
Yes.
So only this slide.
The entire presentation. Can you represent it?
From first, sir.
This slide, from this slide.
We are not able to see your screen, Divya.
Is it?
Can you check present now once again?
Okay, sir.
Yeah, now it's visible. You can go to the presentation, Dr. Divya.
Okay. So now it's fine.
We are still not able to see the presentation, Dr. Divya.
So what is seen actually?
The screen, infinity mirror, your own screen is, the Google Meet screen is seen.
Okay.
We apologize for the inconvenience. Please be online.
So just see now. So can you see the screen?
Still, I'm able to see only the Google Meet screen. Could you share your presentation to me? I can present it if required.
Sure. 1 second.
The participants are requested to wait a few more minutes. We are facing a technical glitch. We'll resolve it shortly.
The last time I'll just try. If not possible, I'll share you the PPT.
Okay.
My screen is visible.
Yes, now it's visible, Dr. Divya. You can go to the slide.
Is it visible for everybody?
Yes.
Okay, sir. Sorry for the interruption. So continuing with the topic, infrastructure design in the medical laboratory. So I was just telling about the different different types of lab at different levels. So I just told labs at primary level, secondary level, and tertiary level. Apart from that, there are different labs that are called the reference laboratories, research laboratories, and specific disease reference laboratory, which will provide services for complex and special tests. Labs at the hospital level, private clinics, and standalone diagnostic centers. So all kind of medical laboratories are mainly involved in carrying out the tests on the clinical specimen to obtain the information on the patient that will help in the diagnosis, treatment, prevention of the disease, and clinical research. So the infrastructure of the laboratory varies with the requirements of the clinical research or the services provided by the lab. But the basic requirements should meet certain standards. So let it be a small lab, big lab, or a medium-sized lab. But the infrastructure will mainly depend upon what are the kind of requirements you will be, what are the tests or what are the services you will be offering from the lab. Infrastructure of the laboratory will directly impact the quality of the research data, efficiency, and the safety of laboratory workers. The management of the laboratory is responsible for providing adequate resources to the staff to ensure efficient working in the laboratory. So coming to the functions of medical laboratory, I'm sure everybody will be aware what, or rejecting the diagnosis which is already made. Again, the test will help in the prognosis of the disease or the therapy and follow-up of the treatment. It will help in detecting the disease. Labs can also give training to various medical students and also the other technicians. Labs are also used in various research purposes. So coming to the sections of the laboratory, there are various sections. Anatomic pathology, clinical microbiology, clinical chemistry, hematology, blood bank, molecular diagnostics, and reproductive biology. In anatomic pathology, again there are subdivisions like histopathology, cytopathology, and electron microscopy. In clinical pathology, it can involve urine analysis or fluid analysis. In clinical microbiology, there are again subdivisions like bacteriology, virology, parasitology, immunology, and mycology. In clinical chemistry, again, there are subdivisions depending upon the type of test like enzymology, toxicology, and endocrinology. Hematology is an area which includes mainly the automated analysis or again manual analysis of blood cells can also be done. Again, here coagulation system also like PT, APTT or BTCT also come under this hematology department. Blood bank involves the testing of blood specimens in order to provide blood transfusion and related services. Molecular diagnostics along with cytogenetics is again other department. Reproductive biology including semen analysis, sperm bank, and assisted reproductive technology. These are the subdivisions of the in the medical laboratory. So depending upon the requirements in the laboratory, these can be made. NABL classifies labs in a different way depending upon the samples received. So it will classify as small size lab, medium size lab, large size lab, very large size lab, and labs at multiple locations. A lab which receives samples less than 100 or up to 100, it is called a small size lab. Lab receiving 101 to 400 subjects per day is called a medium sized lab. Lab receiving samples more than 400 to 1000 subjects is called a large size lab, and samples if it is more than 1000 subjects it's called very large size lab. A lab with more than one location in the same district with same legal identity, we call it as multiple location lab. So we'll just see what are the floor plans in a lab. Lab should have a separate waiting area, separate toilet for the patients, collection area, sample receiving area, clinical working area as a separate for clinical biochemistry area, hematology section, and separate area for storage and sterilization room, a separate toilet for staff pantry area, waste discarding area, separate sink should be there for discarding the waste. It should not be combined with these sinks which is there in the working area. And a separate exit should also be there preferably, where machines or any other consumables can enter, and also it acts as a fire exit. This is the basic requirements in the lab. If there are more other sections which are involved like microbiology section or PCR section, so it can be planned accordingly. Sometimes even if the histopathology section is involved or sterilization room, tissue culture room, we should have separate divisions for each and everything, because if histopathology is there, you need a separate area for grossing, separate area for tissue processing. If electron microscopy is there, it should have again a separate room. If tissue cultures are there, you should have a biosafety level room should be separate. And if fungus cultures are there, isolation rooms should have a separate isolation. So the planning is according to the requirements. But certain things which has to be considered are you should consider a separate area for a reception area, specimen collection area including patient's toilet. The collection area shall have a workbench, space for the patient seating and hand washing facilities. Specimen reception, registration and sorting out area. Other supporting areas like cleanup area, sterilization area, storage area for reagents, appropriate storage for inflammable liquids if it is used in the lab, and refrigerated storage for reagents. Disposal activities for contaminated waste should be separate. The blood storage, refrigeration should be separate. If there are areas for office meetings or staff, and again separate area for staff room, lockers and toilet should be separate. If hot air oven or muffled furnace is used, you should have a separate area as hot zone area because the heat produced in this area will be very high and you should have with good ventilation system. If you're preserving some retained sample, again you should have a separate area with proper demarcation for the finished products and active raw materials. So these are the areas which are actually very much important in any kind of lab, whether it is a small lab, medium lab, or even without considering the requirements. But these small areas should be there. Coming to the space requirements and location of the laboratory, lab should be preferably located in the ground floor. But by chance, if it is located in the above floors, a good lift services should be there so that both the samples from IP and OP cases can reach to the lab as soon as possible. The minimum space requirement for the lab is 5 to 7.5 square feet per 2 bed or 0.7 to 0.8 meter per bed. That is, in a 50-bedded hospital area, at least minimum of 25 meter square area is must. If it is a 100-bedded hospital, at least 50 meter square area. This is the basic minimum requirement. The space should be there for a lab, irrespective of the test which is considered, depending upon the sample receiving and depending upon the type of test which will be done in the lab. So other factors what can be considered when designing a lab is open plan design. We can consider this open plan design. With this concept, a lab is built with no interior walls so that it can be reconfigured as necessary. The power supply, data, gases can all be mounted overhead instead of providing to the floors or walls. And this will have modular casework along with the wheels, which can be relocated as and when required. Other factor what you can consider is automated testing system. So automated testing system is an advancing lab technology which is facilitated by open plan lab designs. In this kind of system, analyzers will be arranged along the robotic track that will operate like a conveyor belt. Depending upon the type or number of analyzers, it can involve up to 60 feet along the linear track. It will have an organized flow. It will have cross-contamination control, and it can also minimize the transport and motion waste in these kind of lab concepts. So next we'll see what does the NABL 112 standard say on the infrastructure. According to NABL 112 standard, all the labs should have effective separation for incompatible activities. The autoclave should be there separate for sterile articles, and for decontamination articles should be separate. The lab shall have adequate lighting, power plugs, and uninterrupted power supply. The power supply is very important in this era because all the machines, what we are using, all are automatic machines. So the power supply is very much important. Depending upon the load of the machines required, the power supply should be there. Use of the exposed cables should be kept to a minimum. The laboratory shall have ensure that adequate uninterrupted power supply is available so that there is no compromise of the stored data. All the computers, peripherals, equipments, and communication devices shall be supported in such a way that service is not likely to be interrupted, like internet services or phone services and electricity, all should be available as long as the lab is working in the working hours. There should not be any kind of interruption. The laboratory shall have procedures in place to ensure the integrity of refrigerated and frozen samples or reagents consumables in the event of power failure. If there is frequent power failures in the lab, you should make sure the integrity or the stability of the reagents or the frozen samples is maintained. Whenever possible, the sample processing area should be segregated or it should be separate from the testing area, especially when centrifuges and the automated analyzers should not be kept on the same bench because the vibration which is caused by the centrifuge machine can affect the can affect the quality or the reports of the automated analyzers. So these are the NABL 112 standard about the basic requirements of the lab, about the infrastructure. We'll see few slides on what ICMR says about good clinical lab practices. So according to ICMR guidelines, signage board should be available in the lab. It should have name, registration number, the services which are offered by the lab, what is the working hours in the lab, the contact number in case if the customer or if the patient wants to talk to the regarding any test, what are the fees for different kind of tests, and what are the services offered should be displayed on the outside or within the facility. What are the essential health and certain safety regulation signage should be posted. Emergency and disaster management plan should be available in case if there is any kind of chemical spillage or fire or any kind of accident can occur in labs. So the management plan should be readily available. Uninterrupted power supply, again, it is very important. Laboratory grade water for examination purpose. The TDS of the water supply for the most of the automated machines is very important. So maintain the laboratory grade water. Ventilation and environment control is important. The temperature and humidity is very important in the lab, especially when you are using most of the automatic machines. Temperature is important because the reagents can lose the stability. Again, humidity is important because it can affect the sensitive machines in the lab. Good lighting arrangement should be there. Good communication facilities should be there with the referral centers. If you're transporting any specimens or samples to the referral centers, should be good. If any carcinogens or radioisotopes, biohazards are used, it should be properly marked with the appropriate warning signs. So these are the basic infrastructure facilities which should be there in the lab according to ICMR guidelines. But to avoid cross-contamination, the basic facilities which should be there is, this is mainly to avoid the cross-contamination. You should have a separate reception or waiting area, separate primary sample collection room, separate working area. We should not mix up the sample collection area and working area. And if there are any radioactive materials or any hazardous chemicals used, keep separate place for that. And biomedical waste area, again, it should be completely a separate area. Facility for cleaning glassware, sterilization or disinfection, again, it should be separate. Separate areas for meeting, trainings, administrative work should be separate. Separate area for eating, storing food or drinks, it should be separate. Toilets for staff should not be mixed with the toilets of the patient, it should be separate. Coming to storage areas, you should have certain storage areas for storing specimens, storing samples, and slide storage. These storage areas are separate when compared to the storage areas of reagents and consumables. Separate area for records. Again, records area should not be mixed with the storage areas of reagents and consumables. Lab should have restricted access. Only authorized personnel should have access to the examination and record keeping area or informative system. Additional infrastructure facilities can be added depending upon the requirements of the lab. So these are the basic things what GCLP and what NABL say. More or less, it is the same, especially when it comes to the areas. These kind of areas are basic and it is very important, irrespective of whether it is a small lab or a large lab. Histopathology, in certain labs where histopathology is done or processed, you should have a separate area for grossing, separate area for tissue processing and reporting area. When it comes to electron microscopy area, you will need a bigger room because as the electron microscopy is bigger compared to the normal compound microscope which you use. This is the electron microscope and the room should be a dark room. You should not have any light apart from this artificial lights, and only when required these lights will be on, and you should have a separate proper seating arrangement should be made. This is for the electron microscopy room. It is mainly if electron microscopy rooms are used in certain kind of labs. FNAC room for FNAC will have an examination cot and a separate table for preparing the slide preparation. So this is a small room which you will require only an examination cot and a table for handling the slides. If the microbiology, especially if cultures are reported, you should have a separate biological safety cabinet which is certified at least annually to ensure that filters are functioning properly because of the various infectious bacteria or organisms used in these cases. The labs which perform fungus culture shall be equipped with the incubator to meet the environmental conditions for the isolation of fungi. Again, it depends upon if culture reporting is done. So these are various types of biosafety cabinets. We'll just see few slides on other supportive services. Natural light should be used for providing the requisite illumination. If fixtures should be positioned, it should provide uniform, shadow-free and glare-free illumination of the laboratory benchtop. The light required is in reception area, it will require around 200 lux. In offices, it will require around 400 lux. In working places, it will require around 600 lux. So in the workplace, you should have good lighting arrangement. Electricity, as I told you previously, the labs ensure the adequate electric services is available so that there is no interruption in power supply that may lead to compromise of the stored data. All computers, peripheral equipment and communication devices should be supported in such a way that service is not likely to be interrupted. And if there are any exposed cables, it will be kept as minimum as possible. The various kind of electrical hazards which occurs in the lab, it could be because of damaged or faulty tools and equipment. It can occur because of the inadequate wiring and overloaded circuits. If there are some exposed electrical parts, it can cause electrical shock. Improper grounding, grounding is very important in the lab as it can cause the breakdown of the machine. If there are any damaged insulation, please get it cleared and fixed as soon as possible. And if there are any wet areas, be careful while using the electrical instrument. Floors should be smooth, and it should be made up of a monolithic. Actually, basically, it should be very plain, not with any multiple joints, so that it can be cleaned and disinfected easily. Along with that, it should be non-absorbent, skid-proof, resistant to wear, and resistant to any kind of adverse effect, especially when there is any spillage of acids or solvents. It should be easily disinfection can be done cleanly. If there are tiles, because in those greases, the disinfection can be difficult if there are more tiles or more greases on the floor. Same goes for the wall. It should be free from cracks, unsealed penetrations, and it should be capable of withstanding washing with strong detergents and disinfectants. Coming to the doors, the laboratory doors should not be less than 1 meter wide. Minimum, it should be 1 meter wide. If it is around 1.5 meter wide, make sure one door will be 1 meter and the other door will be 0.5 meter. And all the doors should have vision panels. So like this, vision panels with a coding system to the access of the doors should be there. In laboratories where the use of larger equipment is anticipated, you can think of wider or higher doors. This again depends upon the requirements of the lab. All kind of BSL-2 labs should have doors that are self-closing and have locks. Why these doors are important? Because it will help to maintain room pressurization by affecting the direction of airflow in combination with supply and exhaust ventilation rates. In laboratories, maintaining of temperature is very important. So doors act as a very important to maintain the pressurization. It also controls the spread of fire and smoke to the lab. It secures the lab and its hazardous materials from unauthorized people. Sinks, all the labs should have at least 2 sinks. So especially if it is a BSL-2 kind of lab, the sinks should be situated near the exit doors. If a separate tissue culture room is there, make sure one sink is there in the tissue culture room as well. And don't mix up those kind of sinks with the waste disposal sink. The sink for the waste disposal area should be again separate. And the drain outlet, make sure it is connected to the drain outlet. It should be again connected to the proper drainage system or to the STP tanks. In small labs or the medium-sized labs where good effluent systems is not used, you can consider of pre-treating with sodium hypochlorite solution before discarding it to the municipal waste. In certain labs where BSL-2 kind of lab where infectious agents and cultures are used, make sure also where inflammable chemicals are there, showers and eye showers are very much important. At least one emergency shower and eye wash station should be available in each laboratory. These emergency showers and eye wash station should be tapped to the laboratory water supply, and it should not be very far. It should be within 25 feet from the chemicals or corrosive chemicals which are used. When the tissue culture room is located within the main lab, the eye wash station should be installed immediately or next to the hand washing sink in the tissue culture room, because if there is any exposure of any kind of chemicals or any kind of particles, if there is exposure, you should run immediately within few seconds to wash your eyes or to take the shower. So coming to emergency shower, it should be large and easy to operate controls. It should deliver 0.4 gallons of water per minute. The water nozzle should be 33 to 45 inches, just 45 inches above the floor, and it should be regularly checked and flushed out weekly. Same with the eye showers. So it should be easily handled. So there are different kinds of operating showers, like paddle operated safety shower, hand operated safety shower, hand and full operated safety. Next is pneumatic tube transport system. This again, it is not used in all kind of labs, only in big tertiary levels for hospitals. These pneumatic tube transport systems are used. Pneumatic tubes are systems that will propel cylindrical containers. This is basically, it is used in the phlebotomy section to deliver the samples to the laboratory when the phlebotomy area or the sample collection area is far away from the actual laboratory. So what these will do, you can keep the whatever collected samples neatly packed in the container, and the coding system can be operated after pressing the exact code. These kind of capsules, it is called, these capsules will go according to the operated tubes, and it will deliver wherever it is required. The main use of this rapid sample delivery system is it will reduce the turnaround time and it will deliver the sample as soon as possible. Coming to ventilation, mechanical ventilation system is required with 10 to 15 air changes per hour. System should have adequate ventilation capacity to control the fumes, odors, and also the heat which is generated from the machines of the lab. If inflammable liquids or the chemicals are stored in the lab, make sure it is stored separately and certain safety requirements are followed. Fire extinguishers. The distribution of fire extinguishers is specified by fire code. So fire extinguishers should be kept within the 30 feet of flammable liquid, and each one of you who are in the lab should know how to use those extinguishers. Like if it is available, just by chance if there's any accident, just pull the pin, aim at the base and squeeze this handle and sweep from side to side until the fire is put off. Certain hazard communication signage is important. Each laboratory should have a signage holder for prominently displaying hazard communication information at the entrance of the door. Individual labs should have signage holders that are consistent with the type used by other laboratories within each department or building. So don't use a new kind of signage which is not understandable to others. So use a simple signage which is standard signage should be used. Alarm and monitoring system. The increasing sophistication and fine control of laboratory instruments and the unique quality of many experiments demand closely monitored and alarm systems that can be connected to the individual pieces of equipment or temperature control rooms. This alarm and monitoring system is very good if it is installed properly. Like if there is any accidents, like a fire accident, these alarms can detect the smoke, or if there is any emergency breakage of the glass, or if there is any increased heat production from any kind of the machine, it will send coding to the control panel and the result, and it will immediately send signals as a LED flasher, or if there is a wire, it will sprinkle the water immediately, and it will also make the alarm sound. And if the doors have access and if it is locked, it will release the door immediately. So biosafety levels in laboratory. The laboratories are classified as BSL 1, 2, 3 and 4 depending upon the infectious agents used in the labs. The labs are called as BSL 1 lab if the infectious agents are not known to cause disease in healthy adults. Example, non-pathogenic E. coli. If the infectious agents are associated with the human disease, which can infect by auto-inoculation, ingestion, and mucous membrane exposure like mycobacteria, these kind of labs are called as BSL 2 labs. If the infectious agents which has potential for aerosol transmission and those effects can be very serious or lethal are called as BSL 3 lab. In BSL-4 lab, the infectious agents will have high risk of life-threatening disease, aerosol transmitted lab infection, or agents with unknown risk of transmission, example like Ebola virus. So depending upon the different kind of levels, depending upon the different type of the infectious agents used, labs is classified as BSL 1, 2, 3, 4, and the standards are also, and the requirements what is there required also will be different. BSL 1 will handle low risk microbes, and whereas BSL 4, again the risk will increase. BSL 1 is low risk, 2 intermediate, 3 more risk, and 4 will have high risk microbes. Few slides on NFPA. The National Fire Protection Association is a global self-funded non-profitable organization which was established in the year 1896. It is mainly devoted to eliminate death, injury, property and economic loss which can occur due to fire or electrical and related hazards. So this is a diamond-shaped symbol with 4 different colors and different coding system. So it will have different grading system. Starting from 0, it means very less harmful or no harm, and coming to 4, it indicates it is very harmful. Blue indicates it can cause hazard to health, red is fire hazard, white is specific hazard, and yellow is instability hazard. So for the inflammable liquids, these kind of NFPA diamond symbols are available and it is pasted on these kind of reagents. So before using any kind of inflammable liquids or reagents, make sure you see what kind of danger signs are there. So you can take some precautions before using, or even you can, when you're when you're designing the lab, you can also make sure certain safety arrangements can also be done. So depending upon the type of chemicals used, NFPA will classify the labs as Class A, Class B, Class C. Class A labs where high hazard chemicals are used, 10 to 20 gallons of various flammable liquids can be used. Class B labs are the one where intermediate hazards of 5 to 10 gallons of various flammable or combustible liquids can be used. Class C are low hazard where minimum 2 to 4 gallons of various flammable or combustible liquids can be allowed. So why this infrastructure planning is important for a lab? It is important for easy, smooth running of a lab with a quality report and to maintain good tact, and considering the health and safety of personnel, infrastructure is important. I'd like to give few examples. If there is no good infrastructure, what can happen or what will happen? If there is improper grounding or a frequent interruption of power supply, there can be frequent breakdown of the machine. If there is again frequent breakdown of the machine, results can be delayed and also the quality of the reports can be affected. I told you in the previous slide, if the TDS of water is not maintained, again there will be breakdown of the machines. If the labs are small with many instruments, what will happen? There will be no space for staffs to work, and for us, as a result of it, staffs keep falling sick and absence from work, deficiency of staff, quality can be affected. Again, I would like to say, if humidity and temperature is not maintained also, if there is no good humidity, again bacteria can multiply and it can affect the health of the staff working in the lab. If the lab is very big and less workload, more staff, what will happen? Unnecessary moving around time and they tend to do more mistakes. If the flows are not smooth and regular, bumpy flows, again improper disinfectants and accidents can keep occurring. Interrupted power supply, not maintaining temperature, it can affect the stability of the reagent and again the quality of the reports are affected. Collecting samples in the if the segregations are not correct, when sample collection area and the sample testing areas are same, it can cause unnecessary distractions to the working environment. Planning the infrastructure of laboratory is very important as it directly affects the efficacy and quality of the reports. Depending upon the requirements, what is required for one lab, please plan and construct accordingly. These are my references. Thank you.
Thank you, Dr. Divyalakshmi. It's an excellent presentation with a lot of details into every minute aspect of the infrastructure requirements which we face in the labs. The participants are requested to fill the feedback form, which is there shared in the link.
I would like to ask one.
Yes, Dr. Divyalakshmi.
I would like to ask one question to all the like most of the technicians and doctors who are working lab are here. How is the liquid waste discarded in all the labs, especially in the labs which do not have good effluent system or good STP? Because this is the common question which is there in the NABL audit, especially when it comes for the small labs where it is not followed correctly.
The question is open to all the participants. If anyone is interested in taking it up, you can unmute yourself and respond.
I would like to just show a small this one about the same. So.
Yes, Dr. Divyalakshmi, please proceed.
Hope this time, sir.
We have 2 more minutes.
Okay. Because this is quite important and it is important for especially most of the labs, especially small labs, do not have good effluent tanks or anything and they are discarding into the normal municipal waste. So I just thought of putting up this slide. We should have a separate tanks or separate sinks for discarding the waste, especially for the liquid waste. So the outlet from this sink should be connected to this can be considered and it is not compulsory. It is just in one article which was published and what I feel it can be followed in most of the labs. So the sink outlet can be connected to one plastic container with a valve. So all the waste, especially the liquid waste, can be discarded when the valve is closed. After discarding all the waste, you can pour freshly prepared 1% sodium hypochlorite solution and allow it to stand for 20 minutes. After 20 minutes, you can open the valve and all the liquid waste can be drained out and the solid waste can be discarded into the red bag and given it to the biomedical waste team. Other one is this double bucket phenomena. Like what happens here is you can use a hard bucket with a lid, another bucket with holes, and also make 5 big holes in the base and keep it in this bucket and open all the vacuum and you can discard it. After discarding all the vacuum or all the kind of liquid waste, you can pour 1% of sodium hypochlorite solution, close the lid and allow it to stand for 20 minutes. After 20 minutes, you can lift up this red bucket. All the liquid waste will drain out. After that, this solid can be discarded into the red bag and given to the biomedical waste. So this can be considered because there were so many questions which like in NABL where they were asking how do you give pre-treatment for this kind of samples.
If you connect for already we connected for with the ETP, ma'am.
ETP is not there.
No,
if ETP is available.
No, if you connect it to ETP directly, it is go to our lab directly is go to ETP connection only, ma'am.
Dr. Divya has explained this process for those labs who don't have ETP.
Okay.
Oh, yes.
What you're saying is correct, Mr. Sundaraj. So basically, if you have ETP, we don't have to worry about it. Basically, the plant will take care of it. So those labs who don't have ETP, they can follow this.
Yeah.
Okay.
Yes, Doctor. Yes, Anjali Datta.
Yeah, Dr. Divya, can you please share the slide where you have mentioned the references that you have used? So it will be helpful for all of us. So
Yeah, sure. I will share it in the group.
yeah,
Yeah, sure.
maybe you can just show it. We can take a screenshot or something.
Oh, okay. One second.
Understand? Hello?
Yes, please tell me.
Sir, I didn't fill the form. I didn't get the form, sir. How to fill the form?
I can reshare the link in the chat. Open the Google chat and fill the form.
Yeah, I got it, sir.
Okay, right.
Okay. Sir, I'll receive for all the slides, sir.
Slides. Dr. Zubair, are we sharing the PPT? Anyway, the recording will be shared in the
Yeah.
YouTube.
The recording will be shared.
Yeah, you can have a look at it. Is it okay, Mr. Sundaraj?
Sir?
The recording will be available on the YouTube. Is that fine?
Okay. Yeah, it's fine, sir. No problem.
Okay.
Okay. Thank you.